Now that you have learned how to create the testbed and program it, this lesson will be the Testbed Introductory Challenges. This is going to teach you how to use all of the things that you've just learned from programming and put them to work for you. The Testbed Challenges are broken down into two different parts. We have motor movement and claw movement. Let's begin by looking at motor movement. It is broken down again into three parts: beginner, intermediate, and advanced. In the beginner, you will turn the left motor counterclockwise at half speed for 3 seconds. Now with this, when I say half speed, I'm expecting you to round down to 120 for full speed to make it easier for you to do the math. If you would like to do the math at full speed of 127 and try to figure out what half is from there, I look forward to seeing it. You will need to test your build as you go. Looking at the left motor, you will see what is clockwise and counterclockwise. Is it a negative or a positive? And then you will have to remember exactly what is 3 seconds while you're programming, because we're using milliseconds. You will then stop the motor, you will wait 1 second, and then you will turn on the right motor clockwise or the opposite direction at half speed for 3 seconds. Again, you will stop the motor, wait a second, and turn both motors in the other direction for 5 seconds. So that means in the very end, the motors will be moving in the reverse of their original directions. Next, the intermediate challenge for motor movement. When the limit switch is pressed, both motors will turn at half speed in opposite directions, and the LED will turn on. When the bumper switch is pressed, remember the bumper switch is the one I refer to as the BRB. When the bumper switch is pressed and released, the left motor will stop and the LED will turn off. When the bumper switch is pressed and released again, the right motor will turn off. This is where it becomes important to remember what your delay is in your switches, because if you have too short of a delay, you will feel like as soon as you press the button, both turn off and it's skipping a step. So that is where you may run into challenges. Next, the advanced. When the bumper switch is pressed and released, turn the motors on the opposite directions at full speed. Wait until the line follower reads a level higher than or darker than 2000. Stop both motors. Restart both motors at half speed in the opposite direction for 2 seconds. I would like to point out that between when the line follower reads 2000 and you stop the motors, you should put a short pause in there. Otherwise, you're asking the motors to stop and then immediately go in the other direction, which could cause damage. So you'll restart the other motors at half speed in the opposite direction for 2 seconds. Speed up both motors to full speed and stop them both once the line follower reads a level higher than or darker than 2000. Note, you will need to use the same the white paper method above. Actually, we're not using the white paper method. It is easy enough to use your hand to cover this. That note probably should be taken out. Next up are the claw movement challenges. Again, these are broken down into 3 different parts: beginner, intermediate, and advanced. For claw movement, the beginner is when the bumper switch is pressed, make the claw open at half speed for 1/4 of a second. The claw will remain open for 3 seconds and then close at half speed for 1/4 of a second. This should be simple. This is kind of what we did in the programming testbed challenges. The intermediate challenge. This one actually seems to be the most difficult for people, so I'm going to go through it with you. When the bumper is pressed, make the claw open at half speed for 1/4 second, very similar to what we did before. The claw will remain open until the limit switch is pressed and then close at half speed for 1/4 second. So this time, instead of waiting a specified amount of time, it will wait until bump is pressed or the limit switch is pressed. Once the claw is closed, the LED will flash until the bumper switch is pressed again. Now the flashing part is difficult. This requires you to use a while loop with a conditional, and I will give you a hint. Inside that while loop, to make the LED flash, you will need a minimum of 4 different commands. Well, actually 3 different commands. You'll use one of them twice. Claw movement, advanced. When the bumper is pressed, make the claw open at half speed for 1/4 second. The claw will remain open until the line follower reads a level higher than / darker than 2000. The claw will then close at half speed for 1/4 second. Once the claw is closed, both wheel motors will run in the reverse until the potentiometer is turned above 2400. The motors will stop and the claw will then open at half speed for 1/4 second. The claw will remain open for 1 second and then close at 1/4 speed. If you complete all 6 of these challenges ahead of the rest of your class, there is a backside to this challenge, and it has 3 advanced challenges. Each of these challenges has its own way of working that will challenge what you can do. The first challenge is to create a kill switch. Often in robotics, there is a need for a kill switch to be created. A kill switch will stop a robot in the middle of what it's doing and ensure that it goes no further. This can be used as an emergency switch or an override switch. The next is to create a party bot. You will use the test bed to create 5 different settings so that when the potentiometer is turned, the potentiometer or the brain will read where the potentiometer is located and it will choose which of the 5 actions to do. So remember, the potentiometer is broken down into 4048 different readings. There is a range of 4048. There are 5 readings here. 1 is probably best set to 0. The robot is off and no motion is occurring. You can break up the remaining 4 actions between the 4048 remaining positions in which it could be. For example, if the potentiometer position was turned to, let's say, 1000, the wheels will spin in opposite directions. If the potentiometer is turned to 4000, the claw opens and closes. And then potentially all the way up, you'll see that all actions from 2 through 4 happen at the same time. Finally, the third challenge is to create autonomous activity. The idea here is that you will create a robot that can think for itself. It will move about the room, and when it encounters an object, it will find a way to move around it. It will use different sensors. There are multiple ways of going about this. The robot can close the claws on an imaginary object, alert the owner that it has an object, turn around, and run the wheels for another 10 seconds before stopping. This could be used as a trash-picking robot. You will do this using the test bed and to simulate all the different motion. You do not need to create your own robot in order to do this. If you have any questions, make sure that you ask the instructor.